Assalamu alaikum. Good morning, students. Are you excited to learning something new? Yes. I am learning today is a reliable power method for eigenvalues. First, start from the previous lecture. Previous lecture, I am studying into the eigenvalues and eigenvector problem. Is the numerical analysis code MTH 321 is the numerical analysis. This course is very interesting and a lot of application and study in the previous method, root finding method, integration methods, system of equation method, polynomial methods. But today class I am studying from the eigenvalues and eigenvector problem. But let's see the previous lecture. Dear students, what is the previous lecture? Summary of the previous lecture?
In the previous lecture, we studied about the eigenvectors and eigenvalues. Why we study eigenvectors and eigenvalues, the applications of eigenvalues and eigenvectors, and how to solve the eigenvectors of order 2 cross 2 and 3 cross 3.
Very good. I am studying from the eigenvalues and eigenvector and application of eigenvalue. Previous lecture I am studying. Previous lecture discussed into the eigenvalues and eigenvector problem, problem, and real life application. Important topics are real life. Why we need eigenvalues problem, vector या eigenvalues problem. This question is a very important. Why we need the eigenvalues? Just I am writing into the eigenvalues. Start from the eigenvalues, idea of the eigenvalues and eigenvector. Why are you numerically solve eigenvalues and eigenvalues? Mathematically, in eigenvalues and eigenvector is Ax is equal to lambda x. Ax is equal to lambda x. Ax is equal to lambda x, and A is n cross M matrix, and x is a vector, and lambda is a eigenvalue, and x is a eigenvector. First question: if solution is possible, Ax is equal to lambda x. Yes. If x is equal to 0, the equation satisfies both sides. The eigenvalue and eigenvector is a solution. But we are not interested in this thing. We are interested only x is not is equal to 0. X is not is equal to 0. If I am interested, if lambda is not equal to 0, it's based into the lot of application from engineering and physics problem. I am discussing the previous lecture just into the mass spring problem. For example, consider is a lambda x and lambda y is a problem in the physical system, engineering system, and let's so on. For example,
Sir, if we take x is equal to 0, the equation will be satisfied, then why we are not taking x is equal to 0?
I am taking, if x is equal to 0, then when one solution is exist, We have a lot of solution from eigenvalues and eigenvector problem. And just think one thing. For example, I am engineering problem, and I consider from the physical problem in last class. For example, is a mass spring problem. Yes, the stiffness is K1 and mass is equal to M1, and K2 and mass is equal to M2. Just is a stiffness, and M1 is a mass, M2 is a mass, and K is a stiffness, and I am finding to the displacement x1 and x2. This is a physical problem. And for example, is a mechanical engineering problem. This is a 2 stories and 2 stories building. For example, is a K1 is equal to M1 mass, and M2 mass is equal to M2 and K2 mass. And consider from the engineering problem. For example, I am solve 2 cross 2 matrix. I solve into the 2 cross 2 matrices. For example, A minus lambda I is equal to 0. The matrix is 2 cross 2 and matrix is 3 cross 3. Matrix is 2 cross 2 and matrix is 3 cross 3. Solving easily, but I am solving from to the 4, 5, 6 and 100 matrices. It is not possible. But for example, this problem is an engineering problem, is a Newton law of motion, just is a convert into the mathematical problem. I am thinking about this problem. For example, 2 cross 2 problem, it think the 2 cross 2 matrix. 2 cross 2 matrices. But I am interested into the 100 cross 100 matrix. How to solve the 100 cross 100 matrix? The real life problem. And 100 cross 100 matrix solve mean, for example, if you are making in a building. You think, for example, 100 building floors. How to solve this 100 building floors? How to make the 100 building floors? You just see the 100 building floors and need to the 100 eigenvalues. Agar I need to do the 100 eigenvalues, for example, lambda 1 to lambda n. Lambda 100. and 100 polynomial need into this solve the problem. In this course I am try to solve how to solve the 100 flooring fielding from the 100 eigenvalues. Is this just previous class I am discussing from the determinants of this lambda 1, lambda 2, lambda 3 into up to so on into lambda n. Lambda 1 is the largest value, lambda 1 is a largest value, and lambda 2 is a smallest value. And lambda 1 is the largest value. I think lambda 1 finding the largest and smallest value, it is called the spectrum. Spectrum, what is the spectrum? It is the range of eigenvalues. It is the range of set of all the eigenvalues. Set of all the eigenvalues finding to the eigenvalues and eigenvector. Let's move into the today topics. Today topic is eigenvalues and eigenvector. Eigenvalues and eigenvector. And eigenvalues and how to find the largest and smallest method? Is the only method is the iterative method. Power method is a iterative method, and using the iterative method finding the largest and smallest eigenvalue. So in this lecture I am focusing on the three things. For example, I am today lecture is a headline, today lecture is the outlines. Why we are studying into this, how to solve the eigenvalues and eigenvector problem using the MATLAB window. First, in this lecture, we will learn how to finding the largest eigenvalue, finding the largest eigenvalues, and eigenvector. And second thing, for example, secondly, finding the smallest eigenvalues, and eigenvector. And third thing is focus on to the how to use the MATLAB code, how to write the MATLAB code of this window, how to write MATLAB program from the largest eigenvalues and eigenvector. And fourth thing, how to solve the problem using MATLAB window. Okay, beta? Yes. Understand of all of the things? Yes. Firstly, I am studying this lecture how to find the largest eigenvalue. Secondly, how to find the smallest eigenvalue, and how to write the MATLAB code. All the previous course I am all the program of this course writing into the MATLAB window and solve the problem as manually as well as MATLAB window. Okay?
Yes, sir.
Okay, beta?
Yes, sir.
So firstly move into the slides and just a basic idea of the MATLAB code. Okay, how to the solve of the largest eigenvalues and largest eigenvector. Any question? Okay. For example, I am giving the idea, and after the idea I am sharing from the slides of all the students, and you are easily solve all the problem. Okay? Yes, so first, for example, Ax is equal to lambda x. Ax is equal to lambda x. I am solving for an example, and A is a matrix. A is a matrix. Consider any matrix in 2 cross 2, 3 cross 3, and any matrix A1 2, A1 3, A2 1, A2 2, and A2 3, A3 1, and A3 2, and A3 3. Okay, beta? And firstly, it is the iterative method. It is a iterative method. Iterative means are you finding from this iteration, for example, y1, y2, yn, y up to so on. And how to stopping criteria of this? Atka, how to stopping criteria of the eigenvalues, eigenvalue, how to find the relative error from this problem? What is the iterative methods? Anything?
Value repeats.
Value repeat. It is removing from the error. It is removing from the error. For example, Ax is equal to lambda x is an iterative method. It just from the is considered into the eigen and consider is the initial guess. It's a very important initial guess. Initial guess is not take from the 0 and 0. without 0. For example, you are taking from the initial guess. For example, x vector is initially, you are taking from the next vector 1, 1, 1. You are taking from 1, 0, 0. You are taking from anything else. But you are not taking from the 0, 0. And just idea, this a and x is a multiply. A and x is a multiply. And finding from the, agar if a matrix multiply to the vector, what we will get? Iram? One matrix is multiplied by the vector. What we will get? Matrix and vector? Matrices. No, it's a get into the matrix from the 3 cross 3 and 1 cross 1. It's a 3 cross 3 matrix. It's a 3 cross 1 matrix. It's okay. We will get a matrix. We will get a not matrix. We will get a vector. Or just multiply the first row and first column, first row, first column, second row, second column. It's okay? So, for example, we multiply these matrices and first iteration is, we get, for example, first iteration we get is a for example, first iteration is get a first iteration. First iteration is get, for example, y1 is equal to 2, 3 and 4. Anything else? Is a please first taken into the largest value. Largest value is 5. And 5 is divided by 2 by 5 and 3 by 5 is equal to 1. And furthermore is a first eigenvalue. Lambda 5 is a first eigen. Is it m up to swan lambda 2, lambda 3 and in the stopping criteria defined into the books, for example 2 decimal place, 3 decimal place and stopping criteria of this. Okay, all of the basic concept of the eigenvalues and eigenvalue and largest, how to find the largest eigenvalues and eigenvector. Any question?
Yes, sir.
Ji.
When we're using the matrix here, you said that it can be 2 cross 2 or 3 cross 3. Why we are not using a rectangular matrix? Is it necessary to use only matrix there?
It is a necessary from the square matrix. For example, 100 by 100 matrix, 200 matrix and 300 matrix, and find the polynomial, for example, 200, and it is compulsory using to the square matrix. Okay. Very good question, beta. So let's move into the slides. Okay, basic idea. Reliable power method for eigenvalues and so just into this power method and all the things I am it is the iterative method and square matrix. For example, lambda 1, lambda 2, lambda, it is a descending and increasing order. It is a square matrix having from the lambda 1, lambda 2 and lambda 3 is a eigenvalues. As a step from eigenvalues and eigenvector, I am discussing from already. First is the eigenvector, x is equal to 0, arbitrary eigenvector, and secondly it is iterative techniques. I am earlier mentioned yi is equal to ax into I minus 1 into lambda x I1 to 1, and it is a stopping criteria. The two vectors, for example, is a fourth iteration minus third iteration. Approximation, what we will get? Approximation to 0. And fourth step in finding into the, that is computing the ratio of largest eigenvalues. Computing the previous eigenvalues divided by the previous eigenvector. Previous eigen.
Please explain step 3.
Step 3. Okay. Let's see. For example, it is a iterative techniques. For example, you will choose a x1 is equal to 5.321 and x2 is equal to 5.312. 311. It is a 2 decimal place is a similar. 2 decimal place is a similar. And 5 in x2 minus x1. We will get a 0.00. It is a 2 decimal place. It is okay. It is a iterative method. It is a iterative technique. It is okay from this 2 cross 2 matrix. Okay, na? Acha. Okay, just a few steps from the how to finding the largest eigenvalues and eigenvector. And we take one example. For example, is a 2 cross 2 matrix. A very simple problem. Finding the largest eigenvalues of the matrix and the 2 cross 2 matrix, and using the method into the 2 decimal place. Using the method into the exactly what is the 2 decimal place, Ahmed?
2 decimal places.
The floating value after the decimal is a 0, 0 is enough. 0 is 0 is a, and we take a 2 decimal places in the value. So firstly, we get into the initial eigenvector. You guess into the initial vector 1, 1 and 0, 1 up to 1. You are depending for you. Okay. choose. The first iteration is y1 and x multiply by matrix in the vector. We get into the new vector 1 and 3. Take into the common from largest eigenvalues and 0.00. And again is a x1 vector, and multiply by vector into the x vector is a new vector, and again taking into the largest value. Okay, again taking into the new vector and largest value. How to stop in this criteria?
When the same eigenvectors will be same.
Two eigenvalues is same, and it's okay. I am seeing to the eigenvector in y5. Okay, y5 and 0.417 and 0.7 in the both eigenvectors are similar. Both eigenvectors, your answer is correct and your iteration is stop. And next question, how to find the relative error? How to find the what is the relative error?
Sir, final value minus
When the previous value minus initial value, we get into the relative error. So I am finding into the relative error, and how to find 2 cross 2 is a very simple problem. But 2 cross 2 matrix, you find the largest eigenvalues and eigenvector. The largest eigenvalues is previous values I am already discussing from the previous y4 values and y3. y4 in both values are divided, and both values, and we get into the new eigenvalues. This is the largest eigenvalues is 5.37, 2 decimal place, and choose into the 2 decimal place, and corresponding eigenvector in this eigenvector. Okay?
Yes, sir.
Easy?
Yes.
You are solving from 3 cross 3, 4 cross 4, 5 cross 5, it's okay. You are solving easily. But and finding into the next into the smallest eigenvalues, and smallest finding the into the use into the and firstly solve into this problem 2 cross 2 and 3 cross 3 into the MATLAB window. How to use the MATLAB window in the interested question in this class. Then 3 cross 3 matrix. Please see in the all the problem you are solving easily.
Yes, sir.
Yes, sir.
Okay, just into the initial guess and up to so on and iteration, the 2 vector is similar and iteration is stop, and find the relative error. Your answer is accurate. And last question, how to using the MATLAB window from this problem? How to use the MATLAB window? And I am practically problem solve into the next class, but you are just seeing into the MATLAB window. Let's see the MATLAB window. Okay, any question?
No, sir.
Acha, you are the very interested question how to use the MATLAB window. MATLAB window, for example, your problem is eigenvalues problem. This I am seeing from the practically using into the original MATLAB. For example, it is the largest eigenmatrix from 3 cross 3. Firstly, how to write the MATLAB code into the MATLAB code. For example, you firstly choose into matrix. Matrix 1, 3, minus 1 is used into the semicolon, and the second row write into the semicolon, and third row into the semicolon, and matrix written into the semicolon. Okay, and choosing into the initial guess is very important. Initial guess 1 1 1 and up to so as you wish you be choose kar chahe, or and choose into the choice one. What is the choice one? Choice one, it is a menu command, MENU menu command. Pick into the choice largest eigenvalue, smallest and smallest into. For example, you are using into the MATLAB window, and find, for example, you are the largest eigenvalue in the problem. So you are just choosing into the largest. You are finding the smallest. You are interested into the near to the eigenvalues and choose into the eigenvalue. And for example, into the taking into the loops if choice 1 and store choice 1 if and else is a choice 2 and choice 3. In the first 10 loops are written if and then write into the loops. How to store the variable in loops?
Sir, can you choose the initial guess 0 0 0?
No, 0 0 is not choosing. Other than the 0 column. So 1 is 0, but other two vector is 0. It's okay.
Sir, why?
0 0 is I am not interested from the 0 0. 0 is any matrix multiplied into 0, and answer is 0. What are you finding? Okay, na? Just as a MATLAB window, I am plotting from this screenshot, taking into the slides, and easily you are practicing into this. For example, this menu command is show from this, put into the MATLAB window, and the command window it lists largest value, smallest value, and near to this value. Okay?
Yes.
Choose into the one and pick into the largest, and pick into the store into and pick into the smallest, and up to so on. For example, I am taking the screenshot from all the codes, but I am performing in the class is a one code. For example, okay, any question about these windows? Acha, just taking the next class from the MATLAB command, how to use the MATLAB program of this course. But I'm just, any question about this code, how to write the iteration criteria. For example, let's iteration criteria is using, let's share from the slides. Okay. Acha, okay. So review of this lecture slide, and after the lecture slide, I'm next lecture sharing from this how to use the command window and solving the lots of problem into the eigenvalue and eigenvectors. Acha, firstly describe into the summary of all the lecture. In traditional way from the lectures, my lecture is end of the lectures, I am discussing what are you doing in this class, why are you doing, what is the applications, and today summary. Who is interested to tell me that today class summary and class overview?
How to find eigenvectors and eigenvalues and through iteration method.
Good.
And how to find relative error, and you told us that how to write the code in MATLAB for solving a matrix.
Very good.
We studied the Rayleigh's power method, in which we have to find the largest eigenvalue. The steps are described like we have to choose the largest eigenvalue. We take the common value out of this and then divided it into that, and the stopping criteria is when we get the same eigenvectors, their approximation must be 0. That will give a stopping
And
criteria.
one more point is that we can only take square matrix, not rectangular.
And
very
the
good thing.
initial guess must not be 0, 0, 0.
And all the thing is very good, and the interested thing is the largest eigenpower method is a very important, is a numerical techniques. Numerical techniques, it is not a stop from these 2 and 3 matrices. I am solving the 100 polynomial matrices, 100 taking buildings, 100 mass problems are solving into the lots of application in this problem. But importantly of this problem, how to solve the 2 cross 2, 3 cross 3 and largest eigenvalues into the using of the MATLAB window. Inshallah next class I am solving to the all the problem, how to write the program in this class, and how to write and using the MATLAB window, and how to find, how to solve the problem, all the thing problem, to find largest value, smallest value, and near to this value of this class. Inshallah, see you into the last lecture.
Application of eigenvalue in real life.
Real life, and real life application from eigen I am already earlier mentioned. But is, for example, I am taking just one example into the previous lecture. For example, mass spring problem and story buildings problem. It is a practical problem. For example, you are converting into the mathematical and physical engineering problem to the mathematical Newton law of second m scale laga ke it is equal lambda x. But into the interested thing and the, for example, today is a very interested is the example, for example, Google. I think, why are you Google, when for the searching from the searching engine, why are you working the searching engine like this? For example, you are searching into the numerical analysis course, and lots of pages are open. How to this page is ranking from 1 to 1 and 1 to 3? And originally in 1998, the first time the Google is finding from the page ranking. Find out the page ranking, and it is an extraordinary development into the Google, and first time using into the eigenvalues and eigenvector. And for example, you choose from this eigenvalues and eigenvector. For example, I am thinking just, for example, you are the pages connected from this. For example, is the pages 1, 2, 3, 4, 5, 6, 7, 8. The page ranking 1, 2, 3, 4, 5, 6. It's just few examples. It's a page ranking example. For example, 1 is connected from 2, and 1 is connected from 4, and 2 is connected from 1, and 1 is connected from 4, 1 is connected 4, and 4 is connected by 5, and 6 is connected by 3, and 4 is connected by this, like this. Yes. This page, why are you connected this page is like this? This is a basically eigenvalues and eigenvector problem. Just for example, how do eigenvalues and eigenvector is a work in like this? For example, is the first edge, your first node, your first vertex is right. For example, 1. How to write the total is 6 pages. For example, is a 1 page is considering from the eigenvalue. You are not considering into this your page. For example, you are this page ranking is 0. Page ranking is 0. And how to connect 1? 1 is connected by 2 is ranking is 1. Ranking is 1. 1 is connected by 4 is ranking is 1. 1 is connected by 3 not is equal to 0. 1 is ranking by 5 yes. 1 is ranking by 5 4 3 it's okay. And other is 0. 1 2 3
7.
0. And total page is 6. 1 2 3 4 5 6. It is a 6 enough. Okay.
Yes. Yes, sir.
It is a, for example, first page is a ranking from the eigenvector, and second page, third page, who to connect it from the vertex and edges, who to connect it the vertex and edges. And this is a write into the matrix form. Simply write into the matrix from the 0, 1, 1, 0, 0, 1. And it is like in this, all this page ranking. And using from the diagonal matrix, finding the eigenvalues and eigenvector, and searching. Recently, Google is searching from the one edge from the 200 pages. 200 pages. It is a practical problem from the Google. Okay, madam? Thank you very, very much. And shall I let you?